So we have talked about all of these vocabulary words in class, and we're going to be using those to answer these questions. And so what we need to do is look at the figure and look at the statements that they are making, and then decide which one of these reasons is a good reason to say it is okay for me to make that statement. And so starting with the first statement there, measure of angle 1 plus measure of angle 2 equals the measure of angle ABC. That's a pretty easy one. That is the angle addition postulate. So I'm going to abbreviate things as usual. Then if B is the midpoint of AD, then AB is equal to BD. So again, this is the midpoint. It would say that this distance here is equal to this distance here. That's going to be the definition of midpoint. If BC bisects FBE, then angle 2 is congruent to angle 3. So again, we've got BC here bisecting this angle. Bisect means to cut in half, so this angle 2 would be congruent to angle 3. That's going to be definition of bisect. Angle 1 and angle FBD are supplementary. Then angle 1, the measure of angle 1 plus the measure of angle FBD is 180. So we have angle 1 here. We have angle FBD here. They do form a straight line, so they are a linear pair, which means they are supplementary, which means their measure is 180 degrees. That is definition of supplementary. If CBD is 90 degrees, then CBD is a right angle. So here is CBD. It is 90 degrees. It is a right angle. That is the definition of a right angle. AB plus BD is equal to AD. So AB plus BD is equal to AB. We're adding those two segments together, so that is the segment addition postulate. If measure of angle 2 is equal to measure of angle 3, then BC bisects FBE. So again, FB is being bisected. It's saying that this angle is congruent to this angle. That means that this has to be a bisector. So similar to the one that we did up above, that is the definition of bisect. Angle 3 plus angle 4, the measure of angle 3 plus the measure of angle 4 is 90. Then angle 3 and angle 4 are complementary. So angle 3 and angle 4 make a right angle. Two angles that come together to make a right angle are complementary. That is the definition of complementary angles. ABC and CBD are right angles, then angle ABC is congruent to angle CBD. So ABC is a right angle. CBD is a right angle. They are congruent, and we know that because of the right angle theorem. Right angle theorem that says, the right angle theorem says all right angles are congruent. And then the last one for this page, angle 1 is congruent to angle 2, angle 2 is congruent to angle 3, and angle 1 is congruent to angle 3. So we need to see what's happening here, that we have 1 is congruent to 2, 2 is congruent to 3, and and this 2 is shared between those two things. So since 1 is congruent to 2, and 3 is also congruent to 2, then 1 must be congruent to 3, and since we ended up taking this side of this and this side of this and sticking them together because they are both congruent to angle 2, then they must be congruent to each other. That's the transitive property. You could also technically use substitution. But that's the properties for that page. Moving on. So we've got this proof that's already done. We're actually not going to do the problem that's here. So this one is out. We're going to bounce back here to these. So we have a list of statements on the left. We need to provide reasons that match those statements. And so we can look at what's given. We can see that BD is an angle bisector of ABC. When I read that, I think, oh, angle bisector means that this big angle is being bisected, so what's going to happen is this angle is going to be congruent to this angle. I can just think that at this point because I can't mark the figure until I have the things that I need to be able to do so. And angle ABD is congruent to angle 1, so this angle is congruent to this angle. What we were asked to do is prove that DBC is congruent to angle 1. So this is what we're trying to prove. So the way that I want to go about this, I always want to think through a proof before I start it. So we know that this bisects the big angle, so these two are congruent. And we were also given that ABD is congruent to angle 1, so this one is congruent to this one. And so if this one and this one are congruent, and this one are congruent, then this one and this one must be congruent. That's the proof. That's the process that we're going to go through with this proof. So it was given that BD is an angle bisector of angle ABC, and ABD is congruent to DBC. We can mark that now because of the definition of bisect. We also know that angle ABD is congruent to angle 1. So these two angles are congruent. That was given. And then they are saying that DBC is congruent to angle 1. So we see that ABD is congruent to DBC and it is congruent to angle 1. So since they are both congruent to ABD, they must be congruent to each other. And this is the transitive property. You could put substitution and I would accept it. Okay. B is the midpoint of AC, and AB is congruent to EF. We want to prove that BC is congruent to EF. So midpoint means that this segment is going to be congruent to this segment. We were given that AB is congruent to EF, so this one is congruent to this one. And so we're asked to prove that BC is congruent to EF. So since this one and this one are congruent, and this one and this one are congruent, this one and this one must also be congruent. That's the process we'll go through. So we had the midpoint and the ABEF situation. We're going to mark those. B is the midpoint of AC that was given. AB is congruent to BC, that is definition of midpoint. AB is congruent to EF was given. And now we're going to see that those are both congruent to AB. BC and EF are both congruent to AB, so they must be congruent to each other. That's the transitive property. And again, you could use substitution, and I would accept that. A little bit longer one, N is the midpoint of MP, so I'm going to mark that that is congruent to that. Q is the midpoint of RP, so this one is congruent to this one. And PQ is congruent to NM. So I'm actually going to go back and change my marks to be like this and like this. So all four of those are congruent. So N is the midpoint of MP that was given. Okay, Q is the midpoint of RP was also given. PN is congruent to NM. That's because of the definition of midpoint. PQ is congruent to NM. That was given right here. PN is congruent to PQ. Okay, so PQ is congruent to NM. Sorry, PN is congruent to PQ because they are both congruent to NM, so they must be congruent to each other. That's the transitive property. And again, I would accept substitution if you were to put that there. Now, PQ is congruent to QR. That's because the definition of midpoint. And then last, we have PN is congruent to QR. So PQ was congruent to PN and QR. So since they're both congruent to PQ, they must be congruent to each other. That's transitive. Okay, on to the next. The last one was a little bit weird. So angle 4 and angle 5 are supplementary, and angle 5 and angle 6 are supplementary. Okay, so 4 and 5 make a straight line. That's fairly obvious. 5 and 6 also make a straight line. That's fairly obvious. We are asked to prove that angle 4 is congruent to angle 6. So the way that we're going to do that is we're going to say that these two here make 180 degrees, these two here make 180 degrees, and that they share this angle, they share angle 5. So if we subtract angle 5 from the top angle that makes a straight line, and we subtract angle 5 from the bottom angle that makes a straight line, we would have the same amount left. And so that's the way that this proof is going to go. And it was given that that was supplementary. Measure of angle 4 plus measure of angle 5 is equal to 180. That is the definition of supplementary. Same for the next line. Then, since both of these are equal to 180, they must be equal to each other. So you can see they moved this line down here and this line down here. Since they're equal to the same thing, they must be equal to each other. That's the transitive property. Then we have measure of angle 5 on both sides. So just like solving any other equation, we can subtract the same thing from both sides and it will still be equal. So we're going to subtract the measure of angle phi from both sides, that is subtraction. And then we are left with measure of angle 4 is congruent to the measure of angle 6. That is, we're switching from measure to a congruent statement. That's the definition of congruent. So anytime we switch from measure to congruent or congruent to measure, we're going to say that that's the definition of congruent. Angle 1 and angle 2 are right angles, that's given. We're asked to prove that angle 1 is congruent to angle 2. This is pretty simple because we know that all right triangles are congruent because of the right angle theorem, but let's go through the process. So measure of angle 1 is equal to 90 degrees. Because that is a right angle, so it is 90 degrees, that's the definition of a right angle. Same thing for the other one. Now since they are both equal to 90 degrees, they must be equal to each other. That is transitive. And since we're going from measure to congruent, that is definition of congruent. And that's it for that one.